calibrations. The thermal gradient on this batch looks optimized. See the consistency across the profile.
Yes, the automated adjustments are working.
The manufacturing sequence utilizes high-speed pick-and-place machines and extensively trained technicians, implementing
vigilance. This primary manufacturing sequence showcases our sophisticated automated systems executing wave soldering with executing calibration adjustment tuning with robotic handling systems ensures exceptional precision and quality consistency.
Look at the throughput data here.
Yield rate confirmed. The sequence is successful. Real-time monitoring confirms optimal production efficiency this cycle.
The yield projections are exceeding targets by 10%.
Pictures. This is the advanced systems integration phase, utilizing automated surface mount technology with comprehensive.
Advanced systems integration implementing comprehensive real-time monitoring capabilities and predictive analytics features, maintaining superior manufacturing standards, and maximizing yield efficiency. Advanced systems integration phase meticulously implementing inventory management platforms, emphasizing sophisticated environmental contamination control.
Detailing sophisticated thermal management solutions with comprehensive real-time monitoring capabilities, automated data collection, and predictive analytics features.
Implementing sophisticated signal integrity validation testing with comprehensive real-time monitoring capabilities and predictive analytics features. The systems integration is complete. We're showing full compliance with the IEC standards.
Predictive analytics confirm optimal efficiency projections.
Temperature cycling endurance test results are finalized.
Data logging confirms all parameters met.
Review complete. Authorizing product release.
The resonance stabilized at 42 Hz.
Ratios are holding steady across the Z-axis.
Documentation confirms protocol compliance. The reliability data confirms all specifications.
Agreed. We can authorize the product release.
All parameters are confirmed against the standard protocols.
The thermal inspection data is clear.
Finalizing documentation and authorizing product release.
This confirms the power consumption is stable under load. Good.
Document the thermal management solution results for the final report.
Have you cross-referenced the automated test results with the manual readings yet?
Yes, the signal integrity metrics are within the specified parameters for release.
The analytics platform is showing a deviation. We need to initiate the failure forecast protocol.
Confirmed.
Rerouting wafers now.
The analytics show we've maximized the yield efficiency on this batch.
Confirmed. Standards maintained and quality improved. The Kaizen implementation is showing significant results in quality improvement.
Yes, look at the real-time efficiency data coming through now.
The integrated management system tracks continuous quality improvement in real time.
See the efficiency metrics correlate.
The continuous quality improvement shown here demonstrates the effectiveness of our cross-functional teams in maximizing manufacturing excellence.
The yield optimization methodologies are clearly working.
Throughput capacity is up 20% across all lines.
Monitor the turnover rate. We have a defect alert on screen 4. Adjusting the sensor calibration now. Rerouting components. Efficiency stabilized.
We need to integrate the customer feedback analysis to improve yield efficiency.
And ensure we maintain
By integrating thermal management solutions, we've drastically reduced the warranty return rate shown here. This improves our operational efficiency.
The signal integrity validation confirms the anomaly.
It looks like a level 3 field failure in the Asia rollout.
Our advanced analytics confirm that the new obsolescence framework is maximizing operational efficiency across all The advanced analytics platforms confirm our technology refresh initiatives are maximizing efficiency.
Reliability metrics are up 20% this quarter.
These analytics confirm our compliance metrics are exceeding the new standards.
Continuous quality improvement is evident. The preventive maintenance schedule is working. By combining this fundamental research with the manufacturing applications, we forecast significant competitive advantages.
The integration is successful. We are seeing a 40% increase in efficiency.
This confirms our competitive advantage in the evolving market.
The 5G module assembly is proceeding exactly as planned. The robotic calibration is holding steady within optimal parameters. The new architecture significantly reduces latency at the edge. And the manufacturing yield projections look promising.
The quantum structure is stabilizing, projecting global impact data now.
This confirms the manufacturing viability. The structural integrity holds at 98%.
That confirms the viability for the new transistor design.
We need to ensure this prototype meets the IPC Class 2 standards before scaling up.
I've already cross-referenced the schematics with the regulatory compliance database. If we integrate the robotic arm here, we optimize the workflow.
The simulation shows a 15% efficiency gain.
The digital twin simulation is showing a 15% increase in operational efficiency.
Excellent. Strategic business operations, systematically managing brand reputation management strategies, effectively utilizing enterprise intelligence platforms.
These analytics confirm our sustainable sourcing strategy is working. The latest report shows a
The market analytics show a critical vulnerability
in the Asian supply chain.
Look at these projections. If we implement these frameworks, we optimize our decisions here.
This data confirms we can achieve the Q3 cost reduction targets globally. A complete integrated production ecosystem, strategically positioned within the global electronics supply chain infrastructure network. Here on the main assembly line, workers install the switches and keycaps with precision before the final product moves to quality control for testing.
The assembly process begins with robotic precision, placing thousands of components before the switches are added, ensuring unmatched reliability.
The statistical process control data shows we're maximizing yield efficiency. Agreed, the cost effectiveness projections look good for the next phase.
If we adjust the manufacturing parameters here, we enhance ESD protection.
That impacts the component requirements and our
eaters. The critical design specifications are finalized. Now we focus on the manufacturing parameters.
This quality assurance data.
Based on these thermal simulations, we can confirm the manufacturing parameters meet the performance targets for yield optimization.
The signal integrity analysis confirms the design specifications are met for this component.
Excellent. That ensures reliability in manufacturing.
We use traceability management platforms for documenting critical design specifications and manufacturing parameters.
We need to adjust the manufacturing parameters to address this contamination risk.
The specifications require a tighter
Calibration sequence initiated on the SMT line.
Signal integrity is verified, pass on all channels.
Multimeter readings confirmed. MSL baking sequence initiated.
EMI shielding parameters set. Systems are green for production commencement.
The new program sequence is uploaded. Monitoring the first run now.
Looks stable. Component feed is calibrated correctly.
The optical scan is complete. Yield metrics are nominal.
Consistent quality confirmed.
Acknowledged. We have manufacturing readiness.
Meticulous preparation procedures ensure we meet all specifications and tolerances before commencing production. Implementing electrostatic discharge protection with comprehensive attention to specifications, tolerances, and stringent standards.